Given question, design a DFA over the alphabet set A, B such that every string accepted a start and end with an E. Okay, so let's begin. Here, the first step is to define the language. Step 1 is to define language. Language will contain all possible valid strings, and we begin with the smallest valid string possible. So here in this case, wherein my condition is must start and end with A. So here the smallest string possible is just any, wherein the start as well as end is any. Next I can have A, or A, B, A, or A, or A, B, A, and so on. That is, the condition is it should start and end with an A. Start and end, start and end, start, end with A. Okay, so here, next step is to construct DFA. So let's begin. Okay, we have to follow two rules now. The first rule, begin constructing for the smallest valid string. What is the next rule? Next rule, after you construct DFA for the smallest valid string, complete your DFA, that is, respond to all the inputs at every state. So let's start. Q0 initial state. So what is the smallest string possible here is? It is just an A. That is, even if at state Q0, when I have input A, I should be reaching what? I should be reaching final state. So I make Q1 as final state. So here I have constructed for the smallest valid string, that is an A. Next is to complete our DFA. Right? Next step is to complete our DFA. Q0 has responded to input A. It has to respond to input B. Now at the initial state, if I get a B, that means I am breaking up my rule, that is of starting with an A. So this is not allowed. So we know that every time I am breaking the rule, in case of start with pattern, I have a dead state coming up. So Q0 on input B will reach a state Q2, which is a dead state. As we have already seen the cases of start with pattern, we have seen dead state, right? So Q0 has responded to both input A and B. Coming to state Q1, to reach Q1 from the initial state, I have input A. Now at Q1, if I get an A, is it valid? Yes, it is valid because it is starting with an A and ending with an A. If I get multiple A's, then it is still valid because starting with an A and ending with an A. Right? So can I put up a self loop of input A on Q1? Yes. That is, starting with an A, I can have n number of A's and I am still in final state. Justifies my condition of start and end with A. Yeah. So before we complete Q1 state, that Q1 has to respond to input B, let's focus on state Q2. How do I reach Q2 state from initial state? It is with input B. Right? And input B indicates that we are breaking the rule of starting with an A. That means after this, even if I get an A or a B or any combinations of A's and B's should not be allowed, right? It is not a valid string, so it should never reach the final state. So I know Q2 is a dead state and I put up a self loop of A comma B. So let's focus back on state Q1. Q1 has responded to input A. It has to respond to input B. To reach Q1 from initial state, I have input A. Now if I get a B, this is an invalid string. It should not reach final, right? And Q1 is my final state. What if I show up a transition of B to state Q2, right? So let's check whether this transition is correct or not. If I have a string A, B, A, is this a valid string? Yes, it is a valid string because it is starting with an A and ending with an A. So let's check a machine here. Q0 on A goes to Q1. Okay. Q1 on B goes where? Q1 on B goes to Q2. That is my dead state. Q2 on A goes where? Q2 on A goes to Q2. This is a non-final state. Even if this is a valid string, I am stuck in a non-final state. So this transition of B is incorrect. So I have to show up the correct transition for input B. What will I do is, from state Q1, I show up a separate transition for input B and put it into state Q2, right? And then, in order to handle the case ABA, let's complete the machine. Q1 responded to both input A and B. Now at Q2, if I get an A, it indicates what? This phase. To reach Q2, I have A, Q0 to Q1, transition A, Q1 to Q2, input B. If I get an A, I know this is a valid string and it should reach final state. So I put up the transition of A back to Q1 from Q2. Right? Okay. Now Q2 has to respond to input B. To reach Q2 from initial state, I have input A or n combinations of A, then B. Right? Now if I get a B over here, is it allowed? Is it correct? No. It is an invalid string. Even if I have multiple B's, it is still an invalid string. So I can say that if I put up a self loop of B over here, I will be still in Q2 and I can reach final only with the transition from Q2 to Q1 with input A. Is it clear? Yes? Okay. So that is how we construct up the DFA for the given problem. Step 3 is to define 5 tuples of DFA. DFA is defined by 5 tuples, that is Q, sigma, Q0, F and delta. Q is a set of finite states. So here in our case we have state Q0, Q1, Q2 and Q3. This is a state Q3 over here. Okay, new state Q3. Next, input alphabet set, that is A, comma B. Q0, one initial state Q0. Set of final state, here I have only one final state, that is Q1. And delta is my transition function given by Q cross sigma corresponds to Q. Step 4, state transition table. let's construct our table. Inputs are A and B. This is my delta function. States are Q0, Q1, Q2 and Q3. Okay. Q0 initial state, Q1 is final state. Q0 on A goes to Q1. Q0 on B goes to Q2. Q1 is my final state. Q1 on A stays in Q1. Q1 on B goes to Q3. Q2 on input A and B stays in Q2. Q3 on A goes to Q1, which is final. Q3 on B stays in Q3. Next step, step 5. Give an example, that is check for a valid and invalid string. Okay. For a valid string, I should always be reaching final state, and for an invalid string, I should be reaching a non-final state. Never reach final state. So let's check whether a machine is correct or not. First, we'll take a valid string example. A, B, A, A. Okay. So let's proceed. From state Q0, if I get an input A. Q0, if I get an input A, I am in state Q1. Q1 on input B. Q1 on input B goes to state Q3. Q3 on input A goes where? Q3 on input A goes to state Q1. Last input Q1 on A. Q1 on A. Where does Q1 on A go? It goes to Q1, which is final. So this is a valid string reaching final state. So our machine accepts this string. For an invalid string, let's check. This is our example over here. This is an invalid string. Our machine should reject this string from initial state. Q0 if I get an A. Q0 if I get an A, I reach final. Q1. For input B, Q1 on input B goes to Q3. Next input is A. Q3 on A goes where? Q3 on A goes to Q1. Last input Q1 on B. Q1 on B is now going to Q3. Now this is a non-final state, and this indicates that the invalid string is rejected by our machine. Clear?